All right, so we're over here. I'm supposed to finish 3.5 today. I have finished 3.5. So I'll sneak in very little of 3.6. And I want you to have as much time as possible to work on the quiz. All right, so I'll just give an introduction to 3.6. Next week, I still have Monday, Tuesday, Wednesday to do 3.6. Right? So it looks like then we'll finish okay on time-wise. Thursday, questions and answers. You can ask as many questions as you want on Thursday. And next Friday is our next test, the third test. And then that looks like we have 6 tests total. So we would be halfway through the course, believe it or not, by next week. Okay, so I'll introduce some of 3.6. Looks like we have 1 to 55 odd. We'll start off by, again, showing you the questions for the benefit of those of you who aren't going to get the text and never going to get it. So let's see, page 184, 3.6. I think you can read all of that. And then on the top of the next page, here we go. Okay, so it's pretty painless, I hope. Those are all the questions. All right, so in 3.6, we're doing complex numbers. You may have been introduced to this in intermediate algebra, hopefully. Complex roots of polynomials. Okay, so the first thing we're going to do is define the square root of -1. So I is defined to be the square root of -1. Another way of saying that is if I square both sides, I squared is -1. Now you might say that's not a real number. You're right. It's not a real number. You can't plot it on a real number line, so it's a weird new kind of a number. Okay, so I is defined to be the square root of -1. It's not considered a real number. Okay? Or it's a number that has a property that I squared is equal to -1. Right, then we have something called complex numbers now. Okay, so what's a complex number? Okay, we say Z, that's the name of a number, A plus BI. So what's this A plus BI stuff? A and B are regular real numbers. Okay? This whole thing is called a complex number. Okay, if I only look at A, that's real. If I only look at B times I, that's complex. But there's 2 parts to this weird number. There's a real part and there's an imaginary part. So I can't call it real because there's an imaginary part. I can't call it imaginary because there's a real part. So we make up this new word, complex number. Okay? And don't think of complex as the normal English meaning of complicated or something like that, although they might be considered complicated. But complex number means something that looks like this, A plus BI, like 3 minus 4i. If I say 3 minus 4i, I can't call it real. I can't call it imaginary. It is a real and an imaginary part. So we call the whole thing complex. Okay. Now in this section, we're using the quadratic formula again, quite a bit. Okay, so you've seen the quadratic formula before. And I don't really know why they write it like this. We're used to having the whole thing divided by 2a. It's the same thing, but it's -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and you use that to get solutions of a quadratic equation. We know that. And we know sometimes when we do this, underneath the square root, you might end up with a negative. Okay, so if you end up with a negative, then you're going to have these complex solutions because you'll be taking the square root of a negative. Right? All right. So let's see, what else do we need by way of introduction? Okay, some terminology. Complex conjugate. Fancy word. All right, so if you have a complex number A plus BI, the complex conjugate is A minus BI. Okay, they put a little bar on top, Z bar, A minus BI. You don't have to worry too much about that bar, but we'll use this concept of a conjugate. Okay? So for instance, if they give me 3 plus 4i, the conjugate is 3 minus 4i. Notice it's not the same as opposite. Opposite means you change both signs. The conjugate, you leave the real part alone. See, the A stays the same. You only change the sign of the imaginary part. So plus B minus B. Okay? So if I say 7 minus 2i, the conjugate is 7 plus 2i. You only change the sign of the imaginary number. Okay, there are some interesting properties here And say, do I have to memorize it? No, and I don't even think it's worth writing down on your cheat sheet. Okay, but it turns out if you add a number and its complex conjugate, you get a real number. Get the imaginaries cancel out. If you multiply a number and its conjugate, it turns out you also get a real number. Okay, again, I don't think it's worth memorizing. You don't even have to write it down, just letting you know that that's what happens in this case. So if you take let's say we have a 2 minus 3i times 2 plus 3i, you're going to get a real number. Okay? And we'll observe that when we actually do some problems involving it. Okay? All right. And let's see. Now I'll just give you a little bit of my own introduction. Okay, so complex numbers. Okay, so again, I is defined to be the square root of -1. Okay, we call it an imaginary number. Or it has the property that I squared equals -1. Again, it's not real. It's not a real number. Okay, so a complex number in standard form looks like this. A plus bi, where a and b are real. I is this funny square root of -1. Okay, so a simple example is 3 minus 5i. This is considered the real part. This is considered the imaginary part. And just like a text added, the complex conjugate. Complex conjugate of a plus bi is a minus bi. Okay, I have a little thing here on powers of I. Okay. You can write it down if you want to. Again, do you have to memorize it? I would say no. Just notice that there's a nice pattern there. All right, so I to the 0. We already know that anything to the 0, we want it to be 1, so we want that to be consistent. That's still going to be 1. Okay, and what's I to the first power? Well, we know anything to the first power should just be I. Okay, then after that, it gets a little bit more interesting. All right, and how about I squared? We already made a definition of I squared to be -1. Okay, so I squared is -1. I cubed, well, I can write it as I squared times I, and I already know that I squared is -1. So it's -1 times I, which is -I. Okay, then how about I to the 4th? Well, I to the 4th, I can think of it as I squared times I squared. And I already have I squared being -1. So I've got -1 times -1, which is 1. Okay. In essence, for your final answer, I should never have an exponent. Okay. So your answer should be left with an I. If you ever get an I squared or an I cubed or I to the 4th, 5th, you can fiddle with it to bring it down to either an I or it's gone completely. Okay. Because we now know that I squared is -1. I cubed is -I to the 4th is 1, and so on. You can keep going. Okay, if I have I to the 5th, I can pretend it's I to the 4th times I, and I already know that I to the 4th is 1. So I have 1I or I. So it's just going to keep cycling back. Right? So I have a little table here. You can put it down or not. It's up to you. But it turns out to always cycle for I to the 0, 1, 2, 3, 4, 5. It's going to cycle 1, I, -1, -I, and then bounce back 1, I, -1, -I. Okay, so I have a little mini table here. All of these are equal to 1. I to the 0, I to the 4th, I to the 8th, I to the 12th, and so on. All of these are equal to I to the 1, I to the 5th, 9th, 13th, and so on. So you can see they're 4 apart. All of these are equal to -1. I squared, I to the 6th, I to the 10th, I to the 14th, and so on. And all of these are -I. Okay? If you keep going and following this pattern, I cubed, I to the 7th, 11th, 15th, and so on. Okay. All right, I'm just going to show you a couple of very easy problems from the homework, and then I'm going to stop. So I can give you at least half an hour. We have plenty of time, I think. So you can have maybe half an hour to do the quiz. I should declare these ought to be pretty easy. right? If you add or subtract, you just do like, pretend I is any letter, like X or Y, do the same thing. Multiplication is a little bit tricky because anytime you get an I squared, if you get an I squared, you need to change it to -1. Right? So I'll just do a couple problems and then I'll stop. Okay, number 1, -3 plus I plus 2 minus 3I. So these are both what's called complex numbers, right? Okay, so suppose say add them up. You can probably do this without my telling you. If I said guess what to do, you'd probably get it right. You would combine the number with the number and the I with the I. You'd be exactly right. And that's a good reason why they use I as a letter, even though I is not really a variable anymore. It's a constant. It's the square root of -1. But as far as adding or subtracting is concerned, just do like you did before. So -3 plus 2 is a -1. And then I plus a -3I is a -2I. And that's all you have to do. Okay. Pretty much the same thing if you subtract for number 3, which I wasn't going to do. The only extra complication is you have to distribute first, right? So for number 3, -3 plus I plus 5I, change that to what? That would be -2 minus a minus of plus 3I, right? So -3 plus 5I minus 2 plus 3I, and then combine like terms. So that's not really a big deal. Okay, let me show you 5I. Let me show you 5, and that's about it. So at first glance, it looks like your regular distributive property, and it is, but there's one extra twist to it. 3I times 2 plus I. So you distribute. Multiply by 2, 6I. Multiply by I, 3I squared. Now there's something different about this one, though. Okay? Because you're never supposed to have I raised to any exponent. Okay? Well, we already saw this rules here. If you have I cubed, I to the 4th, and so on. Most of these problems, you're not going to go up that high. A lot of the problems, you're going to get an I squared, though. Okay? And anytime you see an I squared, you change it to -1. Okay, so right here, you don't leave your answer like that, 3I squared. Make it 6I plus 3 times -1. Okay, so that's -1. And then write your final answer as -3 plus 6I. Okay, and about how you write the answer, always write the answer with the real part first, and then the imaginary part second. So in other words, you're not supposed to leave your answer as 6I minus 3. You should write it as -3 plus 6I. That's considered standard form. Real part and then imaginary part. Okay, so whenever you have an I squared, it's -1. Okay, now next time we'll do FOIL. You know, this looks like regular FOIL, and that looks like FOIL and all that. Except notice, whenever you get an I squared, you change it to -1. Now, if you just have regular I, leave it alone. Okay, but when you do any of these other operations that we usually do, if you get an I squared, change it to -1. Okay. All right, that's about it, folks. Okay, so I'm ready to start the quiz. Let me check quickly if there's anything in the chat. And there's nothing in the chat. All right, so get your cell phones, cameras out. We're still recording, by the way, for this. So let me go back and share the screen and show you the quiz. You have the rest of the class period to work on the quiz, but it's not due again until the next class period, which is Monday at 9:10. Okay. Okay, so here we go. Take a picture on your cell phone if you would, please. I'll read it also. So draw the graph of f of x equals, it's x squared minus 1 over x squared minus 4. Okay, I'll say it again, x squared minus 1 over x squared minus 4. And here's all the things that you're supposed to discuss. Intercepts, horizontal and vertical asymptotes, symmetry, limits as the graph approaches the vertical asymptotes coming from the left and from the right. Okay. And what happens as the graph approaches infinity and negative infinity, all those things, just like we did in class. Okay, so I'll read it again and then I'll make this disappear. So f of x equals x squared minus 1 over x squared minus 4. Obviously, you should start by factoring. Right? Do your factoring, and that makes it much easier. Okay, so what are the intercepts? Horizontal and vertical asymptotes, symmetry, limits as the graph approaches the vertical asymptotes from the left and the right. Look at the examples we did for homework. And what happens when the graph approaches infinity and negative infinity. All right. All right, so I'll make this disappear. I believe everybody should have enough time. Worst comes to worst, you can ask your partners in your Zoom room. And even beyond that, this is still being recorded, so you can look at the video later for the quiz. Okay, so go ahead and get started. Let me set up your Zoom rooms. And the ground rules, as usual for quizzes, are once you're in your Zoom room, if you in your group are content, then you can just leave. And then I'll see you next time. It's due, what, Monday at 9:10, so you can work on it the whole weekend if you wish. Okay, so let me set up your Zoom rooms. Again, you'll have a group of either 3 or 4, and then go from there. So go ahead and get started.